All right, so this is the second part of your of 7.2, okay, where we're proving identities or we're verifying identities. So here's your first example. Sine of x minus pi over 2 equals negative cosine of x. So I'm going to be dealing with the left-hand side because it looks more complicated, okay? And since it's sine subtraction of two angles, I'm going to use the sine formula for subtraction or subtraction formula for sine, which is sine can't change sine. So sine can't change sines. Sine stand or S stands for sine, C stands for cosine. Okay, I know that we're multiplying the two. And since sine can't change signs, since this is a minus, this is also a minus. And with the angles, I'm just going to alternate x, pi over 2, x, and pi over 2. Okay? Just with that one statement, sine can change signs, we can figure out the formula. Okay? So now I look at it, sine of x, I can't do anything with. Okay, I don't know the angle measure for that, but I do know the angle measure for pi over 2. Okay, so I need the sine and cosine for pi over 2. So I'm going to draw a mini xy graph here. Where is pi over 2? What is that in degrees? 90 degrees, right? So it's right here. And on this unit circle, pi over 2, this point is 0, 1. And remember that cosine is always your x value of your unit circle. Okay, so that equals 0. Sine is always your y value of that unit circle, so it's 1. Okay? So I'm going to substitute cosine of pi over 2 equals 0 right in here. And sine of pi over 2 equals 1 right in here. Everything else drops down. So this drops down cosine of x times minus, and this drops down sine of x times. Anything multiplied by 0 is 0. So that's a big fat 0 minus cosine of x times 1, that's cosine of x. So 0 minus cosine of x, that's just negative cosine of x, right? And since this is equal to my right-hand side of the equation, I'm done. All right? Questions on this? So my next example I have is this. Tangent of x minus pi over 2 equals negative cotangent of x. So again, I'm going to be dealing with my left-hand side because that side looks more complicated. So first thing, I know it's a subtraction formula. So I have tangent formula for x minus pi over 2. So the subtraction formula for tangent. Now remember, for tangent, I know that it's going to be the tangent of the first angle, tangent of the second angle, over 1 minus the product, tangent of x times the tangent of pi over 2, right? And in terms of the signs, oops, I don't know if it's minus or plus. Okay, in terms of the signs, I know that tangent is sine over cosine. So for my numerator sine, this sign right here, is it a plus or a minus? Tangent is sine over cosine, so sine can't change signs, right? Since tangent equals sine over cosine, Sine can't change signs. So since this is a minus, this is going to be a minus. Cosine, crazy cosine switches signs. So since that's a minus, this is going to be a plus. Okay? So that's what I got so far. So again, I can't do anything with tangent of x, but I can do something with pi over 2. I know the tangent of pi over 2, right? So I go back to my pi over 2. We just did it with example 5, 0, 1. I know tangent is sine over cosine. So the tangent of this angle pi over 2 equals sine over cosine, which is 1 over 0, which is undefined. Okay? Once you hit an undefined, you can't do anything. So there's nothing really I can do here. Okay? There's nothing I can do. So I went down a wrong path. So you can kind of erase it or just cross it out. Okay? So let's rethink this. My left-hand side is tangent of x minus pi over 2. I know this, right? So let's put it into sine over cosine. If I put tangent of x minus pi over 2 in terms of sine over cosine, that would be sine of x minus pi over 2 over cosine of x minus pi over 2. Correct? Yeah. Right? Because x minus pi over 2 is just an angle. Okay? So it's a complicated angle, but it's still nonetheless an angle. So I can just pay sine over cosine, right? And we just, in our example 5, we just did this, correct? So I can show you guys the steps again. These would be the steps, right? So we came out to be negative cosine of x. So I'm just gonna kind of fast forward and make my numerator equal to negative cosine of x, right? That's example 5, okay? Right? We need a cotangent of x, but I know my numerator boils down to this, right? Or simplifies down to this. Okay, cosine of x minus pi over 2. Crazy cosine switches signs. So it's CCSS, cosine of x, cosine of pi over 2. It switches signs, so since that's a minus, this is going to be a plus. Sine of x, sine of pi over 2. No, it's not negative. It's just pi over 2. So again, cosine is 0, sine is 1. So I want to plug in those values into my denominator. So I have cosine of x times 0 plus sine of x times 1. Right? In my denominator. If I plugged in cosine of pi over 2 and sine of pi over 2, I get 0 and 1. So if I simplify this, cosine of x times 0 is 0, plus sine times 1, that's just sine of x, right? In my numerator, I have negative cosine of x. Cosine over sine is cotangent. Okay? Questions on that? No? So my last one here is this complicated looking one. So I'm going to be working with my left-hand side again, because this looks a little bit more complicated than this. Okay? So when I look at my left-hand side, I think of that looks similar to my tangent, right? Subtraction or addition. So I look at that and I notice that the signs don't match up, right? One has to be an opposite, right? There must be a plus in there, but they are both minuses, right? So I can't use that. So what I'm gonna do is I'm gonna turn every tangent into sine and cosine. Okay, use one of those tips again. So tangent of x turns into sine of x over cosine of x, minus tangent of y becomes sine of y over cosine of y over 1 minus sine of x over cosine of x times sine of y over cosine of y. Right? Now these two fractions, they're both fractions on my numerator and denominator. So then I'm going to take apart numerator, simplify that. I want to take the denominator, simplify that, and then put it together. So in this color, I'm going to simplify that. Okay? Actually, maybe not in this color. Yes, it will be a different color. In this blue, I'm going to simplify this. Okay? So I'm going to get the common denominator between cosine of x and cosine of y. What is the cosine of x, cosine of y common denominator? Yeah, multiply the two, right? So we're going to be multiplying the two. So cosine of x times cosine of y. So here in my first fraction, right, sine of x over cosine of x, I need a cosine of y, correct? So sine of x times cosine of y over cosine of x times cosine of y is actually equal to this first fraction, right? Minus, here I would need to multiply both top and bottom by cosine of x, right? In order for me to get this denominator. So cosine of x times sine of y, right? I got that. Questions on how I got that? Now I look at it, and the numerator of this fraction looks similar to one of my addition and subtraction formulas for cosine and sine, right? Because I'm multiplying sine and cosine here, right? And I'm subtracting the two, so it looks similar, right? So you take out your formula sheet and you try and look at that. If you don't have your formula sheet, I just take the first letter, SCCS. That sine can't change sign, right? That works out. So I know it's a sine function if it is anything of x and y, because those two are my two angle measures. And since sine can change sign, since that's a minus, this is also a minus. So we got that. Cosine of x times cosine of y. Right? That makes sense? So this is a simplified version of my numerator up there. Okay. And this color, I'm going to simplify that. Okay. So first, it's going to be 1 minus sine of x times sine of y over cosine of x times cosine of y. I just multiplied these two to get the same, to get it into one fraction, right? So now it's 1 minus that, so 1 over 1, between a 1 and cosine of x times cosine of y. Get the common denominator, which would be cosine of x times cosine of y, correct? So here, I will need to multiply both my denominator and numerator by cosine of x times cosine of y, right? So cosine of x times cosine of y times, here I don't need anything because it already has that denominator. So I'm going to rewrite minus sine of x times sine of y. So again, I notice here that cosine of x, cosine of y, I'm multiplying the two, I'm multiplying these two. There's a minus sign between them, so I'm subtracting those two. It looks like one of those sine, cosine, addition, subtraction, right? So I look at the first letters of each, C, C, S, S, that's crazy cosine switches sine, right? Those fit. The angle measures, they are alternating. So it's a cosine addition or subtraction, right, of my two angle measures, x and y. And since crazy cosine switches signs, since that's a minus, this is a plus. Yeah, over cosine of x times cosine of y. That's my simplified version. Okay? That makes sense? So when I put it together, I have sine of x minus y over cosine of x times cosine of y over cosine of x plus y over cosine of x times cosine of y. Right? Putting the two together. So here, when I have two fractions, I can multiply by its reciprocal. So that's sine of x minus y over cosine of x times cosine of y times cosine of x times cosine of y over cosine of x minus y, or plus y, right? And then this guy and this guy, they cancel out to be my right-hand side. Okay, so my right-hand side is here, which is the same thing as that. Any questions on this? Yeah, it's like the same thing we've been doing. We're just simplifying. Yeah. Right. That's the only difference. We're just adding more formulas to your bank of formulas. Cool. That's the lesson for today. That's 7.2. And I'll see you on the next one.